ideas that the other group had. I think the big one is that interspecies competition is kind of the major determining factor on barnacle distribution at the lower limits of the zone. And then at the higher limits of the zone, it's very much determined by physical factors as opposed to interspecies competition. And then the third thing that we kind of touched on in the paper was that this idea of how snail predation affects the distribution of the barnacle. And this also kind of turned into a muddy point for us, because I think at one point in the paper, it states that there's an increased mortality rate for barnacles inside the cage where they're protected from predation at high tidal heights. And so this was kind of a little counterintuitive to what we thought, because when we would think that the barnacles outside of the cage would have a higher mortality rate because of the snail predation. So that was our question, was kind of why that is. And then our other muddy point was figure 5, which was just really hard to understand.
Cool. Yeah. So if you were there yesterday, you saw a modified version of figure 5. I've already thrown figure 5 under the bus several times today and yesterday. There is a better version of figure 5 in the slides from yesterday if you want to check it out. But you can also basically read the abstract of this paper and get the gist. And Andrew did a great job, and Fiona did a great job of talking about these two things that are really important about this paper, is that this paper shows us that competition and predation dictate the lower range of these species. So as the species is trying to move towards a more preferable environment, which would be underwater or down in the intertidal, it's not able to do that because of competition and predation. As it's forced up by competition and predation to a certain zone, it can only go so high up in the intertidal because of physiological stress. So abiotic factors and its own physiology limit it on the upper half. I think that's really, really important. And we talked about competition a lot in group 1. Here, I'm glad you pointed out the snails. We can talk about predation being important as well. That's a really good thing to point out. As for why more snails have more success feeding in the uncaged, or in the cage, in the cage plots versus the uncaged. Caged barnacles were consumed at a higher rate. Yes? Is that what you said? Yeah.
They basically, oh, sorry.
No, you go ahead.
We found higher, like in high tidal heights, they basically found higher mortality rates among barnacles inside the cage than outside the cage.
Yeah. So sometimes at higher tidal heights, the snails don't make it up there. So there must have been some reason why inside of those cages we had a problem. It's also possible that when they put those cages down, they missed all the snails. And the snails were just like, dope, now I'm stuck in this cage full of food. And they ate all of the barnacles. Science is very imperfect. I don't have the answer because I haven't ever asked this guy what the answer is. It's important to note this paper came out in 1961. It is essentially the beginning of marine ecology as a quantitative science. That wasn't that long ago. Joseph H. Connell is still alive. That's how young the field of marine ecology is. I like to point that out because I think it's fun. Okay, we're going to change from animals to plants and start talking about Jane Lubchenco's paper from the Rocky Intertidal. Before we do that, I forgot to tell you a little bit of background about these people. So I just told you about Connell. He's your classic ecologist, white dude with a beard. Yay, exciting. Jane Lubchenco, on the other hand, is an amazing woman in science who is kind of a personal hero of mine. She was the administrator of NOAA recently during the Obama administration, and she just like is so awesome and amazing and totally rocks. And she's super like science famous. So that's her. Okay, group 3, tell us what you learned.
Yes. So We found that the mid zone was dominated by fucoids and that the low zone was dominated by chondrus in New England. And we also touched on how the upper limits of chondrus was due to desiccation, which is the drying up or water loss. And lower limits were due to sea urchin grazing. And then another point was that the reason why chondrus dominate the low zone is because the organism's encrusting holdfast is resistant to removal. And so the chondrus regrow upright tally from the crust, which allows high resilience to any disturbance. And so our muddiest points were, we were having trouble figuring out the main takeaways for figure 1 because there are just a lot of moving parts and numbers that we kind of needed help with understanding. And then we were also talking about the difference between crust and tally. And then we weren't able to get a question, but my question was, so the paper talks about upper limit and lower limit, and I'm just not sure if they're referring to the number of species or that the upper limit means that there's a large number populating an area, or lower limit means that there's a small number of organisms populating the area. So just a definition of the terms there.
Can you say the term one more time?
Upper limit and lower limit when it's mentioned in the paper.
With regard to the crust or to something else?
Yeah, the crust.
Okay, cool. All right, so let's talk a little bit about this paper. You totally nailed it. Basically, the whole point of this paper and the last paper were to show you how zonation works and what dictates the zonation. So you were perfect when saying, you know, the chondrus is the Irish moss, or the chondrus, which is in the red algae zone, is limited by desiccation as it moves up, which means it basically has to be submerged or close to submerged all the time. It likes to be wet. It really does poorly when it's not. And as it moves down into the subtitle, it's delicious. People eat it too. The urchins love it. They eat it up. So that's why it's kind of controlled predation on the bottom, desiccation on the top. And it's the same for the other species, the fucus species, only they're a little bit higher up in the intertidal, which was a really good thing you pointed out. So great job with the kind of concepts of the paper. Figure 1. So if everybody's looking at the paper, figure 1 is on page 338, which is like several pages down. Importantly, these old papers have mostly like hand-drawn figures, and they're kind of hard to understand. The point here really is that when you remove crust, which the chondrus can grow out of the crust, when you remove that encrusting chondrus, there is space for the fucoids to grow in. So if you remove that stuff, and the littorine snails especially, because the littorine snails are predators for your fucus, the fucus will succeed. So you can see that there's 2 columns. There's a left column with an ABC and a right column with a DEF, and those are 2 different places. And they're showing you the same trend over time in 3 different treatments. The top treatment is a control where there are snails, there is chondrus crust. The middle plot is there are snails, but they remove the thalli of the chondrus. And then the bottom one, they scrape the crust and the thalli off of the chondrus, and there are snails. So there's no snails on the right, there are snails on the left. And you can see that if there is both no crust and no snails, that your fucus does great. Yeah, that's pretty much the point of the paper and of the figure. And it's not super well worded or easy to see in the figure. The other question you asked was about crust versus the thalli. So the crust would be just like the encrusting form of the algae on the rock, which is essentially the same as in this case, not always, in this species, a holdfast style thing. The holdfast is the thing that keeps the animal in place, the organism, the plant, not the animal. The organism in place on the rock, so that's what's the attachment point. And then the thallus is the body of the algae. So that's the difference. We're talking like, about the crust versus the body of the algae, which is like an actual fleshy stalk. And this organism is really cool in that when there's a crusting part of it, it can grow new stalks. So that's what that's all about, which means if you don't remove the crust, they can grow back. And then you asked about the upper limits of the crust, and it was just poor wording. It's really, it's defined by the competition on the bottom or the predation on the bottom and the desiccation on the top. Cool. Really well done. Let's get to group 4, and then we're going to switch gears here in a minute. So go ahead, group 4.
All right. So, we don't have a whole lot to add to the key points. Obviously, zonation of the algae, especially the fucoids and chondrus, and the factors causing that, especially desiccation and predation. And then the whole paper really focused on the fucoids and chondrus, but that takes us into one of the muddier points was, well, not so much a point, but because they were trying to do the species and all the species go together, like you can't talk about one without talking about other species involved in predation. There did get to be a lot of species. And for us, this being our first week, it was kind of hard to keep track of what's eating what. So that was one of our muddy points. And then the other one was the same thing about those upper limits, and kind of them having a hard time defining that. And I think it might have been because this was one of the first studies done on that. Is that right?
Yeah, the first study of any consequence, I would say, done on this was this one.
So, and that's what we based our question on too, is what the authors of the paper or author thought those factors would be for other species. They had gone over the desiccation in this paper, but they hadn't quite stepped into the littorines and other things like that, and what other upper limit factors there would have been.
Yeah, that's a really good question about upper limits, and which abiotic or environmental factor is going to control a species is totally dependent upon the adaptations that individual species has. Like the snails can move, right? So if they're like, oh man, it's too hot and dry here, they're probably going to like move. But they do have a big shell, which helps them with desiccation. And a barnacle has something similar, only it can't move. So it really does depend on the adaptations. And that's something that we covered in more detail yesterday in lecture when we were talking about adaptations in the rocky intertidal. So I would encourage y'all to check that out if you can. This is one of the first, if not the first paper to really look at, what's going on with the algae species in the rocky intertidal, because before people were like, whatever, they're just algae, nobody really cares. And that's an oversimplification for sure, because they taught us a lot about how ecosystems can be structured. And again, I'll kind of go back to what I said about the Connell paper. These two papers in this ecosystem are perfect for showing these ecological concepts that we're talking about right now, because the rocky intertidal is simpler than most ecosystems, and there's very clear zonation, and there's usually like one thing that controls the upper limit and one thing that controls the lower limit, and like the limits are vertical and really visibly obvious. So that allows us to use these as kind of a type study for understanding these principles. So when you go out into your ecosystems, that's the whole point of like this whole week, is like, what do you do when you're out looking at your ecology near me? You can try to apply these principles of zonation and of competition, predation, and abiotic factors controlling different ecosystems and different organisms, and come up with hypotheses based on those to try to understand like why what you're observing is happening. So these concepts that I'm talking about are really broadly applicable, not just in the rocky intertidal. So you don't have to just be looking at snails and algae and barnacles to talk about competition, predation, desiccation, wave action, whatever. All of that is really applicable. So niche partitioning, realized versus fundamental niche, kind of things like that. And that's something we talked about on Tuesday. So we talked about how the fundamental niche is really like the amount of space in an environment that your organism is able to live in. Like if there were no other things around, the organism would be like, I would live between A and B, right? But because there are other organisms and other factors at play competing or eating or whatever with this other organism, they're going to have a realized niche space, and that realized niche space is going to be smaller than their fundamental niche space. So the realized niche is going to be some proportion of their fundamental niche where they're able to exist. and kind of coexist with everything else in the ecosystem based on principles of predation and competition and interspecies relationships, as well as the abiotic factors. I know we haven't written those words anywhere in any slides, but I wanted to make clear that those are ecological concepts that we're considering to be kind of inherent to this process. And I know that you'll see those in the papers. So everybody did a really great job with that. And I think that you've got the general idea down pat. So I'm pretty comfortable with, you know, the questions that I would be asking on the exams. Y'all just like spit out all the great answers just now. So off to a great start in that regard. Cool. Well, everybody just take a deep breath, grab a drink. We're going to move to the next stage of our class, which is R. And we may not get through everything that we're supposed to get through today. I'm going to keep going until it's over. But if you need to leave because class is over or whatever, like that's okay. And it's all going to be recorded. And I'm happy to talk more about it in office hours, yada, yada, yada. All right, here comes that screen share. Say hello to Mount Fuji. Here it comes. Hi, Mount Fuji. So sad it's gone. Okay. I can still see all of you. I can still see the chat. So feel free to like wave around or send me a message or whatever if you're confused or need me to go back or repeat something. We are here for your ability to learn R. So like if we don't get through it all, so be it. Let's just make sure we understand what we're getting through, okay? Go team. So this week in R, if you want to open up your R assignment, week 2, data manipulation in R. This is when we're really going to get into the nitty gritty of like why we're even worrying about R. I'm going to show you how R is faster and easier and like so much more powerful than a spreadsheet. And we are going to tease a little bit about how to make really pretty, beautiful, fun figures in R, which is like part of the whole point that we're learning R. We're learning how to make figures and we're learning to do statistics and we're learning a transferable skill that's going to help you with your projects and hopefully with like your future life. Okay. So pull up this tutorial if you can, and also pull up your RStudio. Within RStudio, if you have forgotten, I'm going to go over quickly. You need to open up a new script. You're welcome to work out of an R Markdown document. So file, new file. You can either select R Markdown or R Script. If you work in R Markdown, that's totally fine. Just remember, you have to make a code chunk. I'm just going to work in R Markdown. Week 2. Yeah, we're going to call it WEC 2 because spelling is dumb. Cool. Week 2, where'd it go? Here we are, is our R Markdown file. I'm going to close the files that I worked on Tuesday with everybody who isn't here. So remember when you open an R Markdown file that it gives you a whole bunch of nonsense? You can just delete all of that because who cares? Just a reminder, making code, mecking, spelling is so hard, making code chunks. I'm writing a comment in R. Making a code chunk, we're going to use what? Control plus what plus what? Who remembers?
Alt and I.
Yeah, so it's Control or Command plus Alt plus I. Control Alt I, and then we get a code chunk. So inside of a code chunk, we actually do have to use the hashtag to make a comment. Outside of it, it's just a regular piece of paper. We can write whatever we want. This is a code chunk. We put code here, and then it runs. Yay. Okay. Cool. So I'm going to work in an R Markdown document today. I usually work in an R script, but I realize that y'all are using R Markdown documents to turn in your homework. So I'm just going to work where you work so that it's a little bit more transferable for you. All right. So data manipulation in R is essentially how to use the tidyverse to make data look pretty. Here I've provided for you a bunch of links to a bunch of tutorials. Many of them are the same tutorials that I provided for you last week. If you are beyond the scope of this class, already better than you need to be for week 2's homework, and you want to continue to learn R, want to try stuff on your own is where you want to live your life. Or you can just start on week 3 homework, whatever. If you need some remedial assistance or you are struggling with some basic concepts, all of these other things are going to be really helpful for you to click on. I encourage you to explore these resources because they will teach you in ways that I am not teaching you. If you just want me to help you teach you in my way, send me a message or like email me or set up a time to meet and we will talk about R until you get it. All right. This week's learning objectives. Oh, one more thing. The best teacher is the Google box. Hit it up. You type R, the question I have, and then you look. If you find Stack Exchange or Stack Overflow, you're probably in the right place. Okay. If you find R documentation, you're probably in the wrong place because that's not ever very helpful. Okay. Learning objectives for this week are simple. We're going to do 3 things. We're going to subset, filter, and trim data. Then we're going to learn how to use this pipe function. And lastly, I'm going to show you how graphs look and that it's very easy to make one, but then I'm not going to tell you how to do it. That's next week. Okay, so what is the first step that we need to do before we do anything else when we're coding?
Is it
Yeah,
like that library function? Oh, sorry.
No, you're good. No, even says it's that library function. Does anybody else have something they think? Coleman.
Get working directory.
Yeah, we want to know, where are we? Like, are we in the right place? So we check, whoops. I'm making comments as we go so you can see. We check our working directory using getwd like this. So we can see we are wherever we are. And I'm in home, J Bauman, bio2319. I actually don't want to be there. I want to be here. So I've navigated using my bottom right user interface back to my home screen, and I've selected a new folder. To set your working directory, you find the folder you want to be in, you go to the More cog in your right screen, and you select Set as Working Directory. You are probably in the right place to start with because you probably haven't bothered to change your working directory since we changed it last week. That's fine. Just a reminder, it's very easy to change your working directory, and you can go anywhere you want, but it's important to note that R doesn't know where to find or put files until you tell it. And if you don't check where you are and you save something to your computer, you'll never find it. So it's important, really good, Coleman, to check your working directory first. Step 2 for us is what Eben said, which is we're going to load some packages. So we're going to make a new code chunk, and we're going to do some librarying. We're going to go to the library, and we're going to find the Tidyverse book because it is the Bible of R. We are going to go to the library, and we're going to pick out the vegan package because we're really, really hip, and because that's where the Iris dataset is hiding. So I'm going to make a couple comments here. The vegan dataset is, or the vegan package is for the Iris data, and the Tidyverse package is for literally everything. Heart, heart, heart. Okay. We love us some Tidyverse. Just a reminder, the Tidyverse is more of a way of life than a package. It's like 50 packages in one. It does everything. Those of you who have learned R before that have not used the Tidy architecture, I'm going to show you how to do things within and without the Tidyverse, and you do you. Don't let me tell you how to live your life, or anybody else for that matter. Okay. So thanks for the reminders, everybody, on what we do first and second. We check where we are in our computer, we make sure we're where we want to be, and then we load up our packages. Every time you turn in code and every time you turn on your Tidyverse, every time you turn on your R, I want you to library some packages at the top of your script. It is true, and somebody asked on Tuesday, isn't it true that when you load up RStudio, it loads the packages you had previously loaded? Yes. But like, don't risk it, man. Just load your packages. If you know you're going to need them, load them. Otherwise, maybe they're not there or they're not updated or whatever. Load your packages. Okay. Now, we're going to learn some basics of data manipulation. So I'm going to make a new code chunk. Before that, I'm going to make a comment. Data manipulation. You will learn that spelling is hard.
I have a question.
Please go ahead.
In the instruction, it has something before library tidyverse. It has another code above it for step 1.
It sure does.
So why didn't we put that?
We didn't put that because that is not supposed to be there.
Okay.
That is supposed to be behind the scenes. That is the code that allows you to use Control-Alt-I to make a code chunk. And I genuinely have no idea why you can see that, but there it is. So if you ever see that, it doesn't really mean anything for you. Don't worry about it. Good question, though. It's good to check on these things. All right, so we're going to do some data manipulation. A quick reminder, and I'm going to zoom through this. R, being helpful, has built in a data set for us. It's a lame data set about cars, but it is a data set nonetheless. I made a mistake there. We can look at it with MT cars. That calls it. We can do head of MT cars to look at the top of it. We can do tail of MT cars to look at the bottom of it. We can do all sorts of fun things. We can do STR of MT cars to look at the attributes of it, right? I can look at the number of rows in it if I want. I can look at the number of columns in it if I want. I spelled cars wrong. That'll happen. So we have this data set. We know how to look at it. Now, what we really want to do with it is manipulate it because we are conniving. Just a reminder, while we're here, there are other data sets hidden in our Iris comes in the vegan package, right? And your homework from last time was to find me a data set that you can manipulate from Tidy Tuesday's GitHub page. Most of you chose Avatar: The Last Airbender because you're awesome. Those of you who didn't are also awesome. I appreciated a lot the rap singles rankings and the trees data set from San Francisco. Those are both really fun ones that people on the internet had a lot of fun with. A friend of mine actually made a podcast all about the singles data set to show who the most popular people were in different generations. It was really cool. So I have loaded up a data set called penguins. You can see that it's all about penguins. I like penguins, they're cute. You can get data from anywhere. A really, really quick thing that I promised we'd talk about when you're reading in data, which you learned how to do last week, and you all did right, you can use 2 different functions, and I'm going to write them here. You've got read.csv, which is the one I taught you, and you've got read_CSV, which is the one that Tidy Tuesday people use. They are essentially the same. This is base R, and this is tidyverse or tidyr. They are the same, but without tidyverse loaded, you cannot run read_CSV, okay? So when you copy pasta to the entire thing that had the read_CSV from your Tidy Tuesday data set and it worked, that was lucky because we already had tidyverse loaded. Just recognize that. It doesn't matter to me which one you use. I just want you to know that sometimes you're gonna get an error message and be like, why? And that's why. Okay, cool. So we learned how to read and look at the different attributes of a data set last week. So that was just a quick rundown of everything we learned last week in 2.5 minutes. Now, I'm going to teach you how to filter columns. So I'm actually just going to copy and paste straight out of our tutorial here because it's easier. Let's say we want to select the columns that we are interested in and get rid of all the other columns. So let's take a look at MT cars one more time. There's a bunch of data in here, but let's say I don't really particularly care about some of it. I only want to know the miles per gallon, the cylinders, and the horsepower because I don't know what all those other things are because I don't know anything about cars. But I really want to know how many miles per gallon I get and how that is affected by cylinders and horsepower because I think that that's interesting. So we can use the select function for that. Select columns we want to keep. Tidyverse style. So we're going to use the select function and we type select and then in the parenthesis we choose the data set we're working from, that's MT cars, and then we give it a comma and then we write the title of every column we want to keep after that. So that's select empty cars, MPG, cylinder, horsepower. And you'll see that we make a new data frame where we did keep those. And just a reminder, if we want to actually work with that data frame, we want to give it a name. So we're going to call it short cars, right? Remember how to name it. Some of you, when you read in a data set last in the homework, did not give it a name. If you don't give it a name, you can't call it again. So make sure you give stuff a name. And you can use the left arrow like I used here, or you can use an equal sign. They are the same. So if I type in short cars, now here is short cars. Miles per gallon, cylinder, horsepower. Okay. Yeah, Clara.
Sorry, I'm having trouble getting tidyverse and dplyr to work. I keep getting error messages just saying that the last version can't be unloaded, so they can't use the package. And I've tried like reinstalling the packages and uploading, and it isn't working. So I'm not sure what I should do.
Okay. You are using R on your computer.
Yeah, because when I go to rstudio.bowdoin.edu, it just like keeps loading and loading and never pulls up the page. I'm not really sure why.
Have you used the VPN login? The
I
Cisco AnyConnect?
have the VPN, yeah.
Weird. Okay, that's
like
fine.
I can just keep following along and talk to you about it after class too.
Yeah, we can do this really quick though. If you could just type, can you still see my screen?
Mm-hmm.
If you can type $R.V version, open, close, run, and tell me what it says, that would be really helpful.
It says error in R version run, unused argument run.
Whoa.
So I've also
Googling
used
the
R
answer.
before and I've never gotten problems like this before. So that's why I'm kind of confused.
R session info. So can you instead type session capital I info, open, close, and run that?
Open close package equals null.
You don't have to put package equals null, just nothing
Okay.
inside the parentheses.
Yeah, it gives me a bunch of stuff. It
Okay.
says R version 4.0.0.
Okay, cool. So you have the most updated version of R, which means that's not the
Alright.
problem. Let's chat after
Okay.
class.
That sounds good.
Yeah, because it's going to take a couple minutes to figure out. But I'm positive that we can solve this problem.
Sounds good.
Today.
Thank you.
Sure. Okay, so we have learned how to select columns using tidyverse, but there are other ways to select columns. Using base R, which is like regular old R, we can also select columns. So I've written the code for how to do this, and I'm going to show you now how to do it when I can find out where we're supposed to be. So how do you select columns using just brackets? This is going to be a little bit more confusing, so just bear with me, okay? We're going to name our new data frame short cars 2 because it is the same as short cars, only it's the second attempt. We're still going to use the dataset empty cars. But for base R to do this with just brackets, this is what we do. We say the data frame we're interested in manipulating is empty cars, open bracket. And then within the open brackets, so the brackets are going to look like this. There's going to be bracket, comma, bracket, okay? If we want to manipulate the rows in the bracket, that's to the left of the comma. If we want to manipulate columns, that's to the right of the comma, okay? So we only want to manipulate columns in this case. We are selecting the columns that we want to keep. So we are going to go ahead and type empty cars, open bracket, nothing, and then a comma. Because we don't need to manipulate the rows. We want to keep all the rows. We don't want to mess with them. We're just going to leave them. So we just put the comma there to tell it, who cares about the rows? Let's talk about the columns, okay? The columns that we want to keep are miles per gallon, horsepower, and cylinder. So if we look at main empty cars, miles per gallon is column number 1, cylinder is column number 2, and horsepower is column number 4. And the way that programming languages actually look at data is they count the number of columns and they count the number of rows with like actual numbers, right? So that means columns 1, 2, and 4 are the ones we want to keep. So we're going to tell R we're only interested in columns 1, 2, and 4. Okay? So you're going to see some additional language inside of this, this bracket, and that's the C and the parentheses. So anytime you see a C parentheses, that equals concatenate, which just means to group together. And I'm not going to get into the details of why that works, but if you want to pick more than one column, you have to use the concatenate function to choose multiple columns, okay? If this is super confusing and you understand select, then you never have to use this. Simple as that. If you like complex for no reason, then this is how you want to do it. Also, if you program in another language, which maybe you do, some people do that. This is the same way you can do it in Python almost, and a similar version of this can be done in most Linux-based coding programs, for those of you who are giant nerds like me. So if we run that data, what we'll see is that we get the exact same thing as if we use select. Yes, Andrew.
So I'm assuming the number, just to clarify, the number is the like number column within. So for example, like name would be number 1, and then MPG would be number 2.
Oops. Actually, name is not a column.
Oh, I see. Okay.
MPG is number 1, cylinder is number 2, horsepower is number 4.
Okay.
Yeah, the first column in this data set, which has all the names of the cars, is actually not a column. And that is sort of a weird piece of this data set just being odd. If we look at Iris instead, you'll see that that every column has a name.
Okay.
MT cars is just weird like that. And sometimes that happens. That's a good question. Okay, so that is select and how to select columns using brackets. Next step, we can also select columns and rows to remove if we want. So instead of telling R we want, hello Mount Fuji. Instead of telling R we want to keep the columns, we can tell R we don't want to keep the columns. So select is really easy if you know what columns you want, right? You just tell it, I want these columns. That's all it can do. Where the brackets shine is you can also select the columns you don't want to keep. So if I have 9,999 columns and there's one column I don't want to keep and I use select, then I have to write 9,998 column names. And that's stupid. So to avoid that problem, I can use the brackets and I can say, instead of using C, I use -C for remove and then link them together. And I list all the columns that I don't want. So in this case, that is column 3, and then column 5, 6, 7, 8. And let's see how many columns we have. We did in call, we have 11 columns. 9, 10, 11. And if I do this, it'll be the exact same thing as short cars and short cars 2. Well, you're not confused because you're totally following. If you have a string of numbers that are consecutive like this, 5, 6, 7, 8, 9, 10, 11, you can just do 5:11, and that's the same thing as listing them out. And you'll see that is the exact same thing. So I just showed you 3 different ways to select columns. You can either select columns by telling it, I want these ones, or you can select columns by saying, I really don't want these ones. Whichever one is shorter is the way to be. Okay, so that's selecting columns and filtering data. Move on to the next step here, which is going to be subsetting and using an additional filter function to eliminate large amounts of data like out of our rows. In this case, we're going to use something called the filter function. And the filter function is built into the tidyverse. So I'm going to make a new code chunk. Filter and subset, Control-Alt-I, and I'm going to copy this, and I'm just going to say what we're doing. So we're filtering by factor. All right. So let's say we have empty cars, which we obviously have, I spelled it wrong. We obviously have seen empty cars many times now. We're very bored of empty cars, but we know what it looks like, so we don't have to think very hard about it. When we look at it, we can see that there are cars with different numbers of cylinder. I am looking for the most fuel-efficient vehicle out of the list, basically. And my goal is to figure out the most fuel-efficient car, and then I'm going to come up with a hypothesis to test some stuff. So right now, I'm just like, let's look at fuel-efficient vehicles only. Because I know a little bit about cars, like a little bit, I can tell you that 4-cylinder cars tend to be way more fuel efficient than 6- and 8-cylinder and 12-cylinder cars, which go vroom but don't get good gas mileage. So I'm going to filter my data set to only include cars with 4 cylinders. And the way I'm going to do that is I'm going to go into my tidyverse, and I'm going to use the filter function built into that. I'm going to name my new data set cars 4-cyl, because that's what I'm filtering by. I'm going to use filter. The first thing I put inside my filter function is the name of my original data set, which is MT cars. Then I throw in a comma, and then I pick the column I'm filtering by. The column I'm filtering by is cylinder. And then I say, since I only want cylinders that are equal to 4, I have to type equals equals, and then I put 4 in quotes. I can tell you why we do that if you really, really want to know, but maybe like wait until after class, because it's stupid. Just in coding, equals equals is equivalent to regular equals for normal people. If you type just equals, it's an and or, which is just dumb. But equals equals.
I have a quick question, Professor
Yeah.
Baum.
Go ahead.
Is there a reason you put the empty cars right above in that chunk, or is that?
Oh, it's just because I wanted to show it to you.
Okay, all right. Awesome.
Yeah, no reason, just to look at it. I like to look at data like a lot of times. You don't have to include that. So we're filled.
Sorry.
No.
Kind of going off of that question, does R allow, or does R, like, if we're making all these different code chunks, does R like kind of go through all of them in one, what's it called, markdown?
Yeah, so the way that I think
Like,
I get what you're asking.
R? So like if you didn't say empty cars before this, like, or if you didn't say, like, you said cars 4-cyl in this code chunk and then you reference it again in the next code chunk, would you have to like kind of restate what that was?
You would not. So as long as I run this line of code, I can go further down in my R Markdown document and refer to cars 4-cyl as much as I want, and it will still know what it means.
Okay.
But importantly, typing it doesn't mean running it. Here I have to either select it and run it, or I have to go over to the green run current chunk and run it. And one thing I haven't shown you about chunks is that this entire code chunk can be run at once if I just go over here and click run current chunk. It'll run everything, and if something doesn't work, it'll throw an error. So you can see that I have an error in these read.csv functions because it doesn't know what to read. So if I comment those out, now it'll work. So this is a great way to make reproducible chunks of code. So anything that's related, you put in a code chunk and you run all of it. And if it gets all the way to the bottom and gives you all green lights, then you win. And if it doesn't, then you goofed and you have to figure out what it was. But now R will remember until I close my R session, everything that I ran. So I don't have to restate it again. It's already known. That's a good question. All right, let's go back to filtering. So we're filtering the empty cars data set by cylinder. We only want cylinders equal to 4. So if we run this, you'll see when we run cars 4-cyl that all we have are cylinders equal to 4. Okay, so we did a good job. There's more than one way to do this. We need to confirm that this works first. So one way we can do that is we can use our str function, cars 4-cyl, and we can look at the attributes of our column cylinder. And it's just going to tell us it's a number and that every number in that column is 4. So that's a bonus. If we wanted to use summary of cars 4-cyl, we could. And then it would tell us the average, the minimum, the mean, the max, blah, blah, blah for cylinder is 4, which means that we only have the number 4 in that column. So we did it. Go team. Filtering using subset. So the other way you can filter non-tidyverse is a non-tidyverse way using base R, and this is using the subset function. And there are lots of programmers out there in the world who use R who tell you that if you use the subset function, you are the worst. I use the subset function all the time, so I'm actively the worst. It's fine. It works great. I like it. It's easy, and they can just get over it. People are weird about stuff like this. So the subset function is essentially the same thing as a filter function. mtcars cylinder equals 4. Same exact thing. Only instead of saying filter, we say subset. So you can see that if we run that, it does the same thing. That's copy and pasteable if you want from our tutorial here. So the alternative to filter is subset. It's important to note that for both filter and subset, we can in fact do multiple things inside of each one. So if I wanted to subset by cylinder equals 4, and I wanted to subset by miles per gallon greater than 20, I could do that at the same time. I'm not going to show you how to do that, but if you are interested in doing that, hit up your Google box and see if you can figure it out. It's not very hard. If you want, we can chat about it outside of class, but I'm sort of giving you a challenge problem if you want to explore some coding. Let's check and see what's next on our list. I think that's more or less it until we get to the pipe function. Okay, this is sort of the last big point for the week, and there's a couple of just quick points I'm going to make about this. So I'm actually going to go ahead and just copy and paste from the tutorial into this new R session and show you the pipe function, which is also $$ or greater than %. The reason that that's called a pipe is a long story, but essentially, for those of you who do code, a pipe is actually just a vertical line like the one I just made, and that is shift /. So that's the button right below your backspace button on your keyboard. That's a pipe, and it is essentially an and. So I put an and at the end of a line using my pipe function, and that allows me to run a line of code and the line below it and the line below it all together to make a new data frame. So that means I can do a filter and a number of columns and like a math equation or something all together at once, which just makes it way faster and way more efficient to code. So the way we're going to do it, and I just copy and pasted this, is we are going to have a hypothesis. I think that cars, or I think that miles per gallon will decrease as horsepower increases within cars that have 4 cylinders. So I have a hypothesis, and I'm doing some code to address my hypothesis by filtering my data. So what I'm going to do here is I'm going to name my new data frame miles per gallon DF, or MPG-DF for data frame. I'm going to call mtcars as my original data frame that I'm going to manipulate and do math out of. And then I'm going to use my pipe function, which just means and. So call mtcars and filter mtcars by cylinders equal to 4. And then you'll notice that my filter actually has 2 things happening in it. So I'm going to filter by cylinders equal 4, and I'm going to also filter by horsepower greater than 100 at the same time. So that was my challenge problem from up above. Spoiler alert, this is how you do it. So called mtcars, filtered by cylinder and horsepower is greater than 100. And I'm going to do some math. I'm going to summarize the results by calculating the minimum, the maximum, the mean, and the standard deviation of the miles per gallon of all of that. So I'm going to run this chunk. And then let's look at the result. It is actually only going to be 1 line, so looking at the head makes no difference. If we run MPG-DF, what we'll see is the summarized min, max, mean, and standard deviation of cars with horsepower greater than 100 that have cylinders equal to 4, okay? So we're working towards kind of understanding our data in order to test our hypothesis. If I really wanted to test my hypothesis, I would have also looked at horsepower less than 100 and done the same averages and compared the 2 to see which one was higher and which one was lower. Does the idea of the and/pipe function make sense? Everything else I've shown you line by line, and now I'm showing you how to link it together in a useful way. The pipe is going to be your bread and butter, or at least the bread that goes around the stuff inside of the bread, which is going to be all the functions you use, if that makes sense. Okay, So that's the pipe. Now, to do something a little bit more interesting and useful, I want to know what the miles per gallon is for every car, or for every group of cars based on cylinders. So does MPG decrease as cylinders increase? That was my original hypothesis, if you'll remember. So I'm going to make a new data frame called MPG per cylinder. I'm going to call empty cars, and I'm going to group empty cars by cylinder. And I'm going to summarize empty cars by miles per gallon. So I run that, and then I type MPG per cylinder, and it does give me an error message, but it still works. And what you can see here is that we have 4, 6, and 8 cylinder cars. We have our summary means and our standard deviations. And if we look at our means, the first glance is going to show us 4 cylinder cars have higher miles per gallon, and miles per gallon decreases as cylinder increases. So now we're learning how to test hypotheses really using R. Yeah, Andrew.
I'm just curious, is the code that Excel uses R?
No. Excel uses a similar style. So this is really common. Most of this kind of column math is really common. Excel uses Excel macro and Boolean, if that means anything. If you've ever tried to actually program your own Excel macros, it's sort of honestly overly complicated. It can be done. Like, truth be told, you can open up Excel and there's a whole bunch of programming you can do in it if you know how to find the programming functions, but they're kind of hidden. You actually have to download like an add-on just to get to them. And then if you run them and save them, you can break Excel forever. I've done it. It's not great. But yeah, Excel's really powerful. It just is kind of clunky. This is a lot faster in my opinion. But if you're an Excel wizard, then like, that's fine. You do you, like I said. But yeah, good question. These kind of functions are really common. All right, that's kind of all we're really supposed to be talking about this week, but I just want to show you very quickly, because I know class is over, what we're going to be doing next week. So I'm just going to show you on the tutorial. I'm not even going to write out the code. We're going to make plots next week. And here's a great tutorial for ggplot. Is actually a broken link, and I'm going to show you how to unbreak the link. So I'm going to click on it, and it's going to tell us that it's dangerous. The reason for that is because Cookbook for R, cookbook-r.com/lowercase graphs is not a real website. But if you copy and paste this code into your web browser and change that G to an uppercase G, all of a sudden it becomes this amazing website with all of the answers on it. I hopefully will fix that link, but you can also just Google Cookbook for R graphs, and you'll find everything you ever needed to know about making a plot in R. All right, so what we're going to do next week is we're going to learn how to make basic scatter plots like this one, where we can use group means and deviations to plot. We're also going to learn how to make a bar plot, even though bar plots are stupid. We're going to get into why bar plots are stupid and useless next week, but they're stupid and useless. Scatter plots, which are notably very different than scat plots, which is how I spelled it, go me, look like this. And they're, again, a little bit more useful when you add error bars to them. So we can now look at our error and see that our errors don't overlap, and suggest that we're likely going to see statistically significant differences between our cylinders. We can also get fancy and make box plots, which just look a little nicer. And then I'm also going to show you how to make really nice looking plots that do cool stuff like this. So get excited about playing with graphic design next week. Your assignment for this week is to learn, practice using the select function, and then also the bracket functions, using a data frame that is whichever one you want. You can also use, I want you to learn how to filter using the iris data frame. So if you're somebody who's having a hard time loading the package vegan, let's talk. So you're going to learn how to use the filter and the subset function. And then I want you to calculate the min, mean, max weight of cars in the empty cars data frame based on the number of gears that they have. So number 3, you're going to need to use group by, not filter, group by. Okay, and then number 4, I just want you to load some data from wherever and calculate a similar thing as number 3. That is all. If you follow the tutorial and just like replace empty cars with your data frame of choice, for the most part, it will work. So I also will have office hours on Tuesday and Thursday, and your TAs will have office hours on Thursday to help you with this. So feel free to reach out. If you can't make office hours, drop me an email. We'll find a time to chat. That's it for the week. If anybody wants to chat about questions they have with R or issues they're having with their version of R, I'm going to hang out for a bit and work people through those kind of questions. So for now, I'm going to stop my share and I'm going to stop the recording, and y'all are welcome to leave whenever. Thanks for sticking around a little late. Sorry it went over.
Thank you.
Yep.